Hello Developer Week people. My name's Phil Legater. This is a screencast because you probably missed my talk at Developer Week because it was on the Monday and most people started on the Tuesday. So this talk's on you have real-time data, you just don't know it. I work for a company called Pusher. We're a hosted service that makes it easy to integrate real-time functionality into web and mobile applications. Now we're one of many real-time frameworks and real-time solutions. So I've been working in real-time technologies for since 2001 when I graduated from university. And so real-time technologies have been around for a long time. But what I often see is that people now discover this vast selection of real-time technologies and they say something like, that real-time framework is awesome, now to find a use for it. And if I had $1 for every time that I heard somebody say that, then I'd genuinely be rich. I'm not kidding. I'm seeing that all the time. So what I really want to do in this talk is convince you that you have real-time data in your applications. And I want to show you what you can do with it, provide some examples of what you can do with it, talk about how you can achieve some of those things at a reasonably low level, or reasonably high level in terms of just exposing that data and how you can use it. And add Q&A. We'll do Q&A in terms of the video, so comments below. So the first thing I really want to address is what is real time, specifically in terms of real-time web frameworks. Now, you wouldn't use a real-time web framework to control something like the enterprise warp core. That would require something that you would class as hard real-time, something where if an event is generated, some data to say, hey, shut down the warp core system, eject the warp core, then that needs to be instantly executed. If you miss the deadline in terms of responding to that event, then there's obviously going to be a bit of a problem. We're going to see the explosion of the enterprise. But I guess the enterprise is the enterprise. Maybe they use some sort of .NET or Java solution. So that probably happens quite a bit for them. Joking aside, what we're really talking about with these frameworks is soft real time. That's the best way to think about it, where it's still very fast. You can still use it for business critical solutions, but you need safety fallbacks. You need to be aware that messages in terms of the delivery from when they're generated to when they're delivered, it might be a little bit longer than you really need. So you need to be aware that you're using the internet as your data delivery platform and it's out of your control. It's not a closed environment. So it's perfectly suitable for loads and loads of different solutions. But you just need to be aware that there's going to be potentially spikes in latency that you wouldn't see in a hard real-time system. So where do you find this data? So I've kind of explained what the technologies that we're talking about, but I want to explain how you find this data within your application. So back in 2011, there was a guy called Mike Brevoort. I can't really pronounce that, sorry. That gave some talks, a bunch of different talks in 2011 on the evented web. Now in those talks he spoke about things like webhooks and Comet and WebSocket, but that wasn't really the main things that I took away from it. Now those were things that kind of power the real-time web. They're the technologies, the protocols, the transports that help power or the paradigms that help power the real-time web. But there were two particular slides that kind of stood out for me. The first one was this. It was 2011, so I'm sure if Mike were to do the slides again, he'd have an animated GIF for this. But there's a gentleman here that's saying, I've got it. When something happens, I'll call you. Now, there's two things there. When something happens, now that identifies that there's an event that has occurred. Something has happened, there's an event. And I'll call you is an example of kind of push. So instead of, I'm sure that many people have seen discussions on WebSockets and Comet technology and server push, where instead of, there would be, the example would be there's a child sitting in the back of the car going, are we there yet? Are we there yet? Are we there yet? And the parent will be responding, no, no. This is the idea of polling, kind of, are we there yet? No. Are we there yet? No. But instead what it should be is when the parent knows that they've arrived, the parent would turn around and go, we've arrived. So we're pushing. As soon as there's new information, we push. So that's kind of what's happening here. I'll call you. The slide following on from that, Mike shows this clear example of push. So there's a change that occurs. Change would be someone makes a change in code base and they push in their code base in their app and they push information to GitHub. Now GitHub then triggers a bunch of different events and informs different third parties about that change that has occurred. It interacts with Jenkins for build, for Boxcar for a push notification, resolves an issue in Jira, or even hits an endpoint on Google App Engine, and that custom script does whatever it wants to do. So we've got change, we've got interactions. So if you think about events within your application, there's loads of events. So where do these events occur within your application? And if you can identify where they occur, you can find the real-time data. So changes and interactions are a really good place for finding this real-time data. Now data changes are a really good way of finding this real-time data, these events, these changes. So standard CRUD, you'd probably remove the R and you just have CUD. Create, new data has been created. Update, existing data has been updated. Delete, data has been deleted. So anywhere you find database interactions, whether it's looking in your code, you find SQL statements. Hopefully not. Hopefully they're stored away in stored procedures and so on. But if you find SQL, then there's interaction with databases, insert, update, and delete statements. Or if you're using some object relational mapping solution, anytime you see interactions with those models, you know there's interaction potentially with the database. Here we create an activity, we get an activity object, we change it and we save it. System interactions. Now any inter-system communication is also some sort of interaction, might identify data changes. Very simple examples are when web endpoints are accessed. There's two examples here in Sinatra. A post request has been made to an interact endpoint, or using Express again, there's a post request being made to an interact endpoint. So anytime that you've got a web service and those web services are interacted with, or if you're consuming webhooks, so callbacks via other HTTP-based systems, or by any other system that making an HTTP call to you to tell you that new data is available or data has changed, that's more real-time data, more events. Logging. Now it's a really simple example, but you're logging information for a reason. You're logging information at different log levels. So if you're logging something at, say, the info level, then surely that data is potentially interesting to expose and to do something with. Maybe the information at different levels is also interesting. So anytime that you're logging, that's an event that you could potentially expose and do something with. So the system interactions are things like web endpoints, logging, cron jobs, incoming email, all sorts of things. Anytime that two systems are interacting with each other, or two components within a system. So user interactions is the next thing to consider. Obviously our applications are full of user interactions if they're user focused. Just simply accessing and viewing web pages or views within an application. Now they are the same as probably interacting with user endpoints. But again, it's kind of user driven and the context changes. It's not a system access, it's not system, it's actually user based. So you get the idea that there's a user that's doing something. So if you have information about that user, then that's potentially even more interesting and more useful. Other ways that users interact with applications all the time, it could be that you don't have endpoints, you have views that change within your application. So it might be a single page app and the views change. But they could click on the UI, they can type information into forms and input elements and text areas. They can drag information around depending on the type of UI that you're building. It could be that they're dragging elements around on the page. It could be that simply the mouse moves. Where that mouse is or where the touches are occurring on the app is an interesting piece of information. And as I said, navigating views. And then there's user-to-user interactions. Now these things feel clearly more real time because they're true user-to-user interactions. If you think about what your application is doing, if you have some sort of commenting, then other people that have commented on that thread, they'll be interested in finding that getting that new information as soon as it's available. Anytime that a user is mentioned, then clearly instantly notify them. That's an event, the mention. Updates to shared data. So everybody's probably used Google Docs. Ultimately, you're updating shared data, but if there's another piece of shared data within a system, you know the users that are interested in that data. When it's updated, that's an event that occurs, and you can potentially expose that to other users. So accessing, viewing web pages, any interactions with the app, and any user-to-user communication. They're all interactions, events, and changes in data. So I hope you're feeling like data now, and you're excited that we found the real-time data in your application. You probably knew it was there anyway. It's just thinking about this over again and trying to expose and think about the interactions and the changes. So data changes, system interactions, and user interactions. So now you've found that data, what can we do with it? The first thing that you can do is yourself, you can go, okay, what's happening in my application right now? So we're just thinking internally. We're not thinking about our customers. We're thinking, what can I do with that data right now? The most obvious use case is some sort of system analytics. So system stats, memory, CPU usage, and errors. So what's happening on the machines that you're running your application on? And then there's what's happening in your logging. So within your application, what's happening right now? You can access this information and build analytics on top of it and understand exactly what's happening with your app right now. You can catch errors early. So say you've just deployed a new version of your application and you start to see spikes in memory or you start to see increased error rates. Then you can roll back that version of that application or quickly push a fix. Because if you look at these logs later, it could be too late and you could have already had some sort of big problem affecting customers, affecting business. So there are lots of tools for this sort of thing already. There's things like Graphite or Liberato or StatsD that allow you to do this sort of thing. But of course, if you're exposing these events yourself, you can potentially build your own solution, something that exposes specifically the data that's useful to you. Website analytics. Now, I'm sure most of us use some sort of website analytics tool. They expose things like what are the popular pages, which users are online right now. That sort of stuff's genuinely really useful, and you can build those sort of things yourself as well. And as with the system analytics, build custom solutions specific to you. Some examples, some real kind of use case examples here are, say you've got an advertising campaign that's going on. You're trying to drive traffic to your site or to use your application, and you're seeing that maybe the ad goals, the goal of the advertising campaign is being achieved reasonably well, but you can make tweaks right now to try and improve that conversion rate. Or it could be that you're finding that it's not converting at all and you're spending lots of money on this advertising campaign that just isn't converting. So you can cancel that advertising campaign and save money right now. An obvious example of this is something like Google Analytics, where they have now a real-time option. And there's loads of other solutions available, but again, you can potentially build your own by exposing this real-time data yourself and building your own very specific solutions. So now that we've spoken about how you can use the data internally and the benefits that you can get from exposing that real-time data and using it internally, what can you build for your customers? What sort of features can you add to your applications that let you benefit and let your customers benefit from that real-time data that you're exposing? So I wanted to cover the use cases. So the general use cases for real-time technology that we've seen at Pusher are that people will start off building simple things like notifications and signaling. So something has happened, data has changed, you know the information that users are interested in, so alert them to do something. So you're notifying the interested parties. In this example here, this is ITV. They've basically got an activity stream looking page, and they're showing the well-known status bar for new updates available. And the point is that they update that, and you can click on it, and the new data will slide in. We see that on the top of twitter.com as well if you're using their web application. Then there's activity streams. So activity streams is kind of the quintessential real-time UI. We've seen that sort of stream of activity on Twitter, on Facebook, on Google+. The example previously, ITV News, it's also an activity stream. Sports have activity streams. We're starting to see the activity stream basically everywhere. And what they obviously are is things have happened, so what's happened previously and what is happening right now. And that's the right now part is the bit where you're exposing the real-time data that you've got within your applications. The examples we see in Twitter and Facebook are what are people that we follow doing right now, what are on Facebook, what are our friends doing right now, or what are the products that we're interested in, what are they publishing right now, and what's happening here. So in both these examples, by knowing who people are following, by knowing brands that you're interested in, they're ultimately subscriptions to data, subscriptions to these real-time events that take place. So we've already got this idea of who's interested in what, so we know who to deliver that data to. Data visualizations are kind of actually the first example of real-time technology that I think about. We used to have flashing displays in the financial industry that I worked in previously. But now that we've got these really nice UI libraries, we can build really rich real-time data visualizations. So in this example, we've got a real-time example of the votes that are taking place in the results in elections. But with sort of charting libraries that we're seeing now and these nice visualizations, we can do really rich things with this sort of stuff. Chat is basically the 101 of real time. It's the first thing that people try to build normally when they build real-time, when they try to use real-time functionality, because it's beyond just simple notifications of data. It's more of an interactive experience that you're building. You can use it to offer assistance to people within your applications. You can also build it as a feature within your applications to let those users interact with each other. And we're starting to see it everywhere. We know how well Atlassian are doing with HipChat, but HipChat I think were acquired by Atlassian, how well Slack are doing, and we're starting to see chat as a core part of many applications, whether it's a standalone app where the focus is chat or as a part of applications. Things like Gmail has Hangouts inbuilt into it, chat. Facebook has Facebook Messenger inbuilt. So that's a core use of real-time functionality, and chat is where an example where real-time really matters. Enhancing the collaboration experience beyond just chat, we've probably all used things like Google Apps. I mentioned the shared data earlier. We're interacting and with this shared piece of data, so that's a good example. The example on screen now is Sprintly, which is a project management solution, and we're seeing lots of people build project management solutions and using real-time functionality in those to identify tickets being updated, or the status of tasks being updated, or comments on specific tasks being added and creating conversations. Or even real-time IDEs like Cloud9, where users can collaborate on code together. Or recently we published something called AtomPair, which is an Atom plugin that lets you collaborate in real time with other developers. And multiplayer games. It's not something I think that if you find data within your application, you're going to build a game out of it. You could, I guess, but I wanted to highlight that it's a use case for real-time technologies. And APIs. If you've found this data and you're exposing this data, either internally or building applications as part of it, if that information is interested to you and users are interested in consuming it, there's also the potential of exposing it as a real-time API for your customers, giving them access to the real-time data in their app, in your application associated with them. So it's obviously focused on more technically inclined customers, but more business-to-business related use case for this type of technology. And you might think there aren't many real-time APIs available, but actually, if you dig into it, there are a lot of real-time APIs. most people have probably heard of the Twitter fire hose and how well they're doing with that. Companies like DataSift get unique access to the Twitter fire hose, offer additional functionality on top of that in terms of filtering and identifying specific things about the data and augmenting that data. And loads of other customers have real-time APIs: Dropbox, Instagram, Uber, Slack, Meetup, a real-time fire hose of RSVPs, PayPal webhooks, HipChat have webhooks, and so on. So all these companies offer real-time APIs, so maybe you could too. So finally, I want to talk about how you do it, how you use this real-time, how you expose it. So you have real-time data in your app, so we've identified that. You know how you can use it. There are some use cases for it, but how do you technically do it? So we've already found our data in our applications. We know where the real-time data is. So you might not be able to expose that data as it is in its raw form. It might need some additional finessing, some additional work done to it before you then publish it to the interested parties. You need to be able to describe that data. So what is the data that people are interested in or systems are interested in? You need to be able to publish that data, distribute it to the interested parties. And the interested parties need to be able to consume and use that information. So you could consider some of this your real-time information architecture. So let's look at analyzing the data. If it's very simple data, then it might not need anything done to it. If it in its raw form is useful, then you can simply use that. There's no processing required. For more complex data, then you might need to consider processing asynchronously. So instead of within that web endpoint where you found that real-time data, doing some processing there, you're going to hold up this web request that's come in, the web endpoint request that's come in. So push it out elsewhere and asynchronously process it. You might need to queue it or store it, use existing database solutions, things like Hadoop or other kind of big data processing solutions. Take advantage of querying solutions. I'll provide an example in a moment around querying and triggers. So some database solutions or storage solutions will have things like triggers when data changes that you can hook into, or change feeds. The example that I want to provide is using something called RethinkDB. So they're a database. In this example, we might be updating a score. So we have a bunch of games that are being played. We get a game ID and we update the score of that game. We execute that command. So that's happened in the normal, a web endpoint's been hit, we've updated that data. Elsewhere in the application, we can have a long-held query. Now what that does is, in this example, we're querying the game plays, we're saying I want to order by the score, I want to limit to 5, so it's basically the top 5 scores, and I want to execute that command. Now that changes function that's been identified is this idea called a change feed. From there we can then have a callback anytime that data changes. We can then loop through the cursor, loop through the update basically, get the top 5 new results and publish that data. So that it's a really nice way of having a query and being informed any time that data changes. So what do I mean by describing the data? People need a way of, and systems need a way of subscribing their interest in data. So they need to identify what is the data. So the common things for this is giving a name for it. And in publish subscribe terminology, that can be a channel or a topic or a subject. They can be simple string identifiers. What is the data that I'm interested in? And then what's happening to the data, I think, is a very, very interesting and important abstraction. So what is the data and what is happening to it? So the idea of what is the event that's taken place. So within simple data, it's quite easy to identify what you're going to call that data, because there could be an existing database schema or document that you're updating. So the table name or the document name that's being manipulated is a very good name for that channel. Or if you're using an RRM solution, the model name itself is another good name for that channel. So it could be, if it's an activity stream, you can have a database or a model called activities. For complex data, I think it's probably best to create a name that's based on the analysis that's taking place on that data or the query itself. So in the complex example I provided earlier, we were executing a query on a table which was basically identifying the top 5 games, top 5 scores. So we could call it top 5 games. And then in terms of, we want to publish that information. So we've got that new data, we've processed it, we've done whatever we need to it, we want to distribute it to the interested parties. So for data changes, in this example we've got our ORM, we're creating a new activity, we're setting some text, we're saving it. In terms of using our API, the Pusher API, we would trigger an event on the activities channel called new activity and then send the activity that's taken place. If we were to update something, we would then trigger an event on the activities channel, activity updated as the event, and pass the activity. And deleted, you've guessed it, activities channel, activity deleted. Really simple, but the evented abstraction, so the channels plus the evented abstraction, I think is really powerful. For the complex example, remember we've got this query, this long-running query. We're querying the gameplays. We're saying order by score. I want the top 5. Anytime a change takes place. In this example, I've got an array. I'm looping through the updated result. I'm building up that array, and I'm triggering the top 5 updated event on the gameplays channel, passing that array of top 5. So I would basically, in the UI, I would update my top 5 table. Just for completeness, I want to provide examples of how you would use the similar API in these different scenarios. So in the endpoint, I would trigger maybe on the endpoints channel a new interaction and say which endpoint it was that had been hit and the post data that was sent to it. In the logging, in this example, I'm using the Winston logging library, and basically I've just created a generic log function, and in there not only do I log, but I also trigger an event on a logging channel with the level of logging that took place and the data. Now, a lot of logging frameworks provide ways of adding other log listeners, so you might actually create a different log listener. You might have a log to file and a real-time distribution log listener. It could be that in this situation you would have a channel per logging level instead. That could be a different way of changing your real-time information architecture. So what about consuming and using? So remember, the data changes are exposed in this example with activities. We've got the activity is new activity, activity updated, activity deleted. So on the client, using our API, now obviously with other real-time frameworks, they'll have similar ways of subscribing and binding to events. I'm using the Pusher API because obviously I'm familiar with it, more familiar with it. We're subscribing to an activities channel. We're then binding to the different event types and having different callback handlers for each of those event types. So for new activity, for activity updated and activity deleted. Really simple, but that's the point of this nice channel and event abstraction. Again, for completeness, here's the web endpoint. We're triggering that event. We're binding to we're subscribing to the endpoints channel. We're binding to the new interaction event, and then we update the UI. In terms of logging, again, it's really simple. We're subscribing to a logging channel, binding to info events, warning events, and error events, so we can partition those different types of events and do different things with them. So hopefully we now know how to identify the real-time data within our application. We've got an idea that we might need to analyze and process that data. We might need to take it out of the kind of synchronous processing. We need to push it off asynchronously if we're doing heavy data manipulation. We need to describe the data through channels. What is the data I'm interested in? The events, what's happening to that data? We want to publish the data and use those same things. We want to publish on channels. The event identifies what's happened to the data, and the payload, the event data itself. And we need to consume it in the same way. So we subscribe to channels, we bind to events, and we use that data payload to update our UI or do whatever, or react within the application in the way that we want. So in conclusion, you have real-time data. I hope I've convinced you. These changes and interactions really help you identify the real-time data within your application. You need to analyze, describe, publish, and consume that data within either internally within your applications or your systems, or building notifications, activity streams, chat, data visualizations, or more kind of interactive experiences for your users. You can obviously use the data internally for analysis, but I do think that, as I've said, that the use case, the value in offering these sort of experiences to users is something that particularly interests me and hopefully you. So I do encourage you to comment. So as I said, this has been sent out to Developer Week, everyone at Developer Week. It would be great to find out if you're already building stuff with real-time technologies. If so, what are you doing? If you're not building stuff with real-time technologies, do you think you've got real-time data? If not, what are you building? Maybe we can find ways of identifying the real-time data in your apps and coming up with ideas of how you can use it. So I hope you found this screencast interesting. Please do get in touch. I'm phil@pusher.com or @Leggeter on Twitter, or comment below. Thank you very much.